Question 18 reads, if the wavelength of an electron is 4.85 times 10 to the negative 7 meters, how fast is it moving? This problem wants you to draw on the de Broglie wavelength equation, which tells us that a wavelength is equal to Planck's constant over momentum. And we know that momentum is just equal to mass times velocity. So this equation will just become m times v. And we actually have all the information that's necessary to solve this problem because we know our wavelength is 4.85 times 10 to the negative 7 meters is equal to, we know our Planck's constant is 6.63 times 10 to the negative 34. And we're going to use the one with joules rather than electron volts because we're dealing with units in meters and kilograms, and also meters per second. Over, we know our mass of an electron is 9.11 times 10 to the negative 31 times our velocity. So if you were to multiply 9.11 times 10 to the negative 31 to the wavelength, and then multiply the velocity over, then we would have essentially 4.85 times 10 to the negative 7 times 9.11 times 10 to the negative 31 times v is equal to 6.63 times 10 to the negative 34. So if you just multiply these two values together and divide it over to the other side, you'll see that the velocity is actually equal to 1,500 meters per second. But because our answers are in kilometers per second, this is just very easy to convert. So this will be 1.5 kilometers per second. So our answer for number 18 is B.